So this is lesson 2 from how computers work, right? So how do computers represent data? That's lesson 2. Who remembers the lesson from last time, y'all?
What is a computer?
Alright, what is a computer?
Something that takes data, processes it, stores it, and then outputs it.
Good. And now we're going to learn how computers represent data.
They do?
Yeah. Okay. So your objectives and essential questions, right, are what is data? How do we represent data? How do computers represent data? Okay. So I'll know so your objectives, right, is I will know what data is, and I will know what a computer uses to represent data, and I will know ways to represent data. Okay? Cool. So what is data? Anybody know what data is? What does data mean?
I don't know.
What's data, bro?
Data is something that the computer stores or has that lets you work out things in different sites.
What's data, man?
Everything entered to the computer.
Yeah. So data is pretty much anything that a computer takes as input or a computer outputs.
Everything entered to the computer is called data.
Or outputs. Anything computer inputs or outputs, right? So data can be video, it can be text, it can be sound, it can be radio waves, it can be shapes, it can be like the keyboard, it can be the mouse, it can be just about anything, right? So data can be hard to represent, store, process, and output, which is what a computer does, remember? So what are some ways you can represent data? What are some ways you can represent data?
Like represent it or to get it?
Like represent data.
Watching YouTube. Watching YouTube?
Yeah.
Because that's data.
Yeah. What are some ways you can represent data? What are some ways you can represent data?
I don't know.
What are some ways you can represent data?
Searching things up.
Yeah. So like ways you can represent data are like you could have like 3 objects and you can either show that there's 3, or you could write the number 3, or you can write 3 in binary, or you can write 3 in hexadecimal. So there's tons of ways to represent data, right? And then how do you think computers represent data?
They take everything you put into them and make it data.
How though?
Can you repeat the last one again?
How do you think computers represent data?
The computer represents data?
Yeah.
The computer processing data?
Yeah. How does it do that? You know?
With a different system, like binary system or something like that.
Binary.
The computer represents data in circuit.
Yeah.
Do you know the circuit?
Yeah, electrical pulses.
Electrical circuit. That meaning if contain electric, that gonna take 1. Doesn't contain electric, gonna take 0.
Good job. Bro.
So they call that is binary system.
Yeah.
0 or 1.
Right.
What?
That's it.
That's
I'm
what we're gonna
confused.
learn.
I know you don't understand.
I'm gonna explain that.
It's
That's in this lesson, actually. Anyway, so
you're gonna
what
listen
you
to
need
that
to
in
know,
the future.
it's in this lesson, actually. So what you need to know is you need to remember that computers are just big calculators, right? And so some ways computers represent data are like Daddy said in binary, right? In zeros and ones. So okay, so what do computers use to represent data? Remember that a computer is just really a machine that does math, right? So remember that every computer takes in input data, stores it, processes it, and outputs the results in some way. So to a computer, all data is binary data, zeros and ones, right? So because the computer really works on electricity, so if the wire has electricity, then it's a 1. If the wire doesn't have electricity, then it's a 0. You know what I'm saying?
You know, you don't
So
understand.
it's basically just yes or no.
Yeah, it's true or false, yes or no.
Nothing like maybe or like okay.
Say, good job. If yes,
we turn on the light.
that meaning it contain electric. If no, that means the circuit doesn't contain electric.
Yeah. So they represent, and then you might be asking how can zeros and ones represent so many different things? And then yeah. So like if the wire has electricity running through it, it's a 1. If the wire doesn't have electricity, it's a 0. And so there's a video, right, that's gonna explain how computers represent data. Y'all ready? Where's the remote? Turn it up.
I don't have it.
My name is Federico Gomez Suarez, and I'm a software developer with Microsoft Acronym. And I'm looking to using technology to help us solve some of the big social problems of the times.
You may have heard that computers work on ones and zeros. Or you may have seen scary-looking visuals like this. But almost nobody today actually deals directly with these ones and zeros. But ones and zeros do play a big role in how computers work on the inside.
Inside a computer are electric wires and circuits that carry all the information in a computer. How do you store or represent information using electricity?
Well, if you have a single wire with electricity flowing through it, the signal can either be on or off. That's not a lot of choices, but it's a really important start. With one wire, we can represent a yes or no, true,
Understand?
false, a one or a
Same
zero,
music.
or anything else with only two options. This on-off state in a single wire is called a bit, and it's the smallest piece of information the computer can store. If you use more wires, you get more bits. More ones and zeros, with more bits, you can represent more complex information. But to understand that, we need to learn about something called the binary number system.
In the decimal number system, we have 10 digits from 0 to 9.
Y'all know
And
these
that's how
digits,
we
right?
all learn to count. In the binary number system, we only have 2 digits, 0 and 1. With these 2 digits, we can count up to any number. Here's how this works. In the decimal number system we're all used to, each position in a number has a different value. There's the 1 position, the 10 position, the 100 position, and so on. For example, a 9 in the 100 position is a 900. In binary, each position also carries a value, but instead of multiplying by 10 each time, we multiply by 2. So there's the 1's position, the 2's position, 4's position, the 8th position, and so on. For example, the number 9 in binary is 1, 0, 0, 1. To calculate the value, we add 1 times 8 plus 0 times 4 plus 0 times 2 plus 1 times 1. Almost nobody does this math because computers do it for us. What's important is that any number can be represented with only ones and zeros, or by a bunch of wires that are on or off. The more wires you use, the larger the numbers you can store.
With 8 wires, you can store numbers between 0 and 255. It's 8 ones. With just 32 wires, you can store all the way from 0 to over 4 billion. Using the binary number system, you can represent any number you like. But what about other types of information, like text, images, or sound? It turns out that all these things can also be represented with numbers. Think of all the letters in the alphabet. You could assign a number to each letter. A could be 1, B could be 2, and so on. You can then represent any word or paragraph as a sequence of numbers. And as we saw, these numbers can be stored as on or off electrical signals. Every word you see on every web page, phone, is represented using a system like this. Now, let's consider photos, videos, and all the graphics you see on the screen. All of these images create teeny dots called pixels. And each pixel has a color. Each of the colors can be represented with numbers. When you consider that a typical image has millions of these pixels, and a typical video shows 30 images per second, and we're talking about a lot of data here.
sound is basically a series of vibrations in the air. Vibrations can be represented graphically as a waveform. Any point on this waveform can be represented and this way, any sound can be broken down into a series of numbers. If you want higher quality sound, you would pick 32-bit audio over 8-bit audio. More bits means a higher range of numbers.
When you use a computer to write code or make your own app, you're not dealing directly with these ones and zeros, but you will be dealing with images or sound or video. So if you want to understand how computers work on the inside, it all comes down to these simple ones and zeros and the electrical signals in the circuits behind them. They are the backbone of how all computers input, store, process, and output information.
Alright. So, what did
Repeat.
y'all learn?
Repeat your slides again to let us understand them more.
What? No, we're gonna talk about it.
The
What did
first-
y'all learn from the video? Did y'all understand the video? What you learned?
I have a question.
Yeah.
How do you know if a signal's on or off?
If it's got electricity running through,
I know, but how do you know?
because it can sense electricity. It's a thing called a transistor.
But how does it sense the electricity?
That's the next lesson,
Okay.
or it's in 2 lessons actually. And I think I was
This is
gonna
a
skip.
good question. You're gonna understand.
I was gonna
More,
skip that
more.
lesson, but it's in 2 lessons. I'll put it in for you. So I'll put it in for you. Okay. So what else did you learn from the video? Yeah, what you learned from the video?
That these little ones and zeros control everything in your devices.
Okay.
Your phones, your laptops, your desktops, your iPads, your TVs. It all runs on ones and zeros.
Alright, what did you learn, Mina? You learned something from the video?
That I learned about all those ones and zeros that I always see on this on like screens everywhere.
Good. Alright.
How is the sound stored and how is the picture stored?
Ones and zeros.
How
Sound is
picture
Electricity.
is stored
Pixels.
in
as a
pixels.
pixels, sound is stored as a vibration or something like that.
Yeah, it's stored. Yeah, they count how fast it vibrates per.
Yeah, vibrate.
Alright, so y'all want to go through the slides again before we play the Kahoot?
Yeah.
Okay, so what is data? Remember, data is anything that a computer takes in or out. It can be anything. And then computers represent data in binary, which is ones and zeros. 1 means it's like electricity is running through the wire. It can represent a yes, a no. 1 bit is either a 1 or a 0, and it can represent one of 2 options. So either a yes or a no, a true or a false, a 1 or a 0. Yeah. Think y'all ready for the Kahoot?
Yeah.
Y'all ready for the
Kahoot
Kahoot?
time.
Remember,
Do you know what
bit,
is how the computer stored?
it stores it in ones and zeros. In
Okay, okay. What is the unit?
Bits.
Bits.
Yeah.
How was a bit? What does a bit mean?
A bit is one of 2 options, so it's either a 0 or a 1.
Good job. We store the information in the computer as byte.
Not bytes.
We say megabyte.
Those are bigger. Those are much bigger. Those are on the next lesson.
Byte equal
8
8
bits.
bits, bro.
And
Good.
then a megabyte is
The byte-
1,224.
The byte contain 1 letter.
Yeah, a byte is
1 letter.
it's a light, an on or off.
1 letter, 1 digit, something like that. 1 pixel.
Yeah, 1 bit.
So every letter contain 8 bits.
Yeah, 8 bits, which is eight zeros and ones.
Yeah, good job.
Which is from 0. It could take. It's a number from 0 to 255.
So the hard disk or memory or something like or RAM,
It
we
reads
measured it with a byte. We say byte, kilobyte,
bit,
megabyte,
byte, kilobyte,
megabyte,
megabyte,
gigabyte,
terabyte,
Terabyte.
petabyte.
Good job.
Those are in the next lesson, by the way.
I know. Okay.
Alright, y'all ready for the Kahoot?
No.
Everybody
George.
ready for the Kahoot?
Understand
Yes.
You
What
follow
is-
along?
what you see?
Alright, let's see how well y'all do in this Kahoot.
What did you
I'm
do?
gonna win.
Bet. Some of the
Wait.
questions are harder than others, but the harder questions give you more points.
Okay.
Alright, you ready?
Not yet. Not yet.
Alright, I'm gonna just let it.
I need my phone, please.
Why did it not?
Where is it? You know where's my phone? I'm gonna get.
And you see 8-bit music, y'all. This works. What the? Okay. It's 8-bit music.
You ready?
Yes.
Ready for your advice?
What is 8-bit music?
Logan.
It's music. You know, we learned about what a bit is, right? A bit is a 0 or 1.
Yeah.
So how a computer stores music is it stores it in sound waves.
No, so you picked it.
It's only 8 zeros or 1s to make music.
Can you take off our friendly nickname?
Alright, ready? Go.
Wait, how many times are we playing this?
It's a 7 question.
How can I
So
enter
can we
too?
play it twice?
How can I enter?
We'll see. You see? You hear how
Just-
low quality
just
the
a
audio
second.
We can't pick our nickname.
Just a second. 8 3 8 1 1 5 0
Can't
enter.
pick your nickname.
Who's Legend Kid?
Spin.
Yeah?
Spin.
Spin يعني.
Click the spin.
Oh shit. No. Game pin.
Click OK. Click OK. Click OK. Click OK.
No. Yeah, no. I wanna write my name.
No. Just click OK.
Okay.
Huh?
Just click. You can't spin.
Why can't we spin?
No.
Click OK.
I don't know.
Oh, that's you, kind of the source?
I don't know what's my name.
Amazing Owl.
That's not me. Bro, I
Alright,
don't want to
ready?
be Amazing Owl.
No, we need our names because I don't know what is my what is my
Can we
name.
restart this?
That's kind of why I had it like that.
No.
I don't know what is my name.
It shows it up. On
Beshoy, why'd you put on friendly names?
it shows it to you on the
It's
thing.
okay. Okay.
Me.
How many?
Alright, how many bits of information can these wires represent?
Bits.
Yeah. So remember, there's 2 wires here. So how many bits of information can they represent?
I don't know. How many? 2 wires? 2?
Yeah. Click something. Oh dang, you ran out of time.
I was first.
Who picked it?
Who picked the red?
Me.
I
Oh.
got it right.
How'd you get 21 from 2
I know.
wires?
I was confused.
Okay, so each of these is a wire, right?
The time is out.
Yeah. It's each of these is a wire, so I put the easy questions.
Wait,
For-
who's in the lead?
Me.
We'll see. Each of these is a wire, right? So
I'm
it either is
educated.
on or off. And that
One.
means it can
Is it
only-
meaning
I
1 bit?
forgot about
1 bit.
I'm
No.
Legend Kitty.
Who's Legend Kitty? Oh, good job.
I'm still taking.
We are 0.
Alright, how many bits of information can these wires represent? Y'all ready?
Mhm.
Alright, how many wires do you see? How many bits can these wires represent?
I was first.
Why is this so long? Okay,
3.
good job. Alright. Which of these can you represent by a single bit? Think about the question. Which of the answer choices can you represent by a single bit?
We can see the
Alright,
3.
so the first one says the warning icon that indicates if the seatbelt is isn't fastened. The second one says the current driving mode, park or drive.
Huh?
The third one says the temperature in degrees Celsius. And then the fourth one says the fill level of a gas tank.
We don't
I
know.
gave you time to think about this one because it's a hard question. You gotta think. Remember, a bit can only represent 2 options.
Yeah.
So which of those has 2 options?
No.
There's
Wait.
multiple answers here. So, which one did you click?
I accidentally clicked green.
أنا
Oh,
مش شايفها أساسا
I
كان
meant to
شيء.
click blue.
which one can't you see?
أختار البلو خلاص أنا مش عارف.
Bro, I tried to click
Blue,
blue.
Who picked green?
Me, I accidentally
You
picked
clicked
green. I was trying to click the blue one.
Okay. Why'd you click green? I'm just saying. You understood the question then?
No.
it says which of the following options can be represented by a bit. So remember, a bit is either on or off,
Yeah.
yes or no.
Yes.
Park or drive, that can be represented by a bit. And then the seatbelt light can be on or off, which is why it's also represented by a bit. You know, so, you know the seatbelt light when you're driving a car?
Yeah.
It can be on or off. It's represented
Yes.
by one bit. And then park or drive is represented by a bit.
That meaning I'm right.
I mean, yeah, you put the right one. Alright, next.
Say the question.
Georgia, first.
Read.
That's
Which of
pretty.
these best describe what a binary digit can store?
Read.
Alright, so which of these best describes what a binary digit can store? So A, values from 0 to 9. 2 single digit values like 4, 8, 1 or 0, and yeet yeet.
EE is the answer. So obvious.
Who hasn't put it in?
Dad.
The brown one, اسمها.
Yeah,
I'm
you
correct.
got it right.
I got blue.
Not blue. We say 0 and 1. Binary system.
I didn't remember. What the?
That was in the video, and
Yeah.
I talked about it.
Mine
Can we pick our own nicknames this time?
Yeah.
The second time?
Fabulous Horse is in the lead. Who's Fabulous Horse?
Dad.
Good
No,
for
that's
you.
me. No.
Alright, what is 10 in binary?
10 in binary.
Or 0, 1, 0.
0, 1, 0. What's 10 what?
No, 1, 0 in binary. So think about it. Binary, remember all the place values
Yeah.
are in 2s. So there's the 1's place and then the 2's place.
2.
Correct.
Y'all are smart.
Yes.
No, I'm George.
Good job.
I'm
I
George.
didn't think y'all were going to get that one, but good job. That means I can take it easy. Which of the following could be represented by a single bit of information? This is like the other one. But it's different answers. Okay, the time of day, a 1 and a 0, true or false, the day of the week. There could be multiple answers.
Yeah, 1 and 0 or true or false.
Yeah,
Both of them.
Wait, why'd you give up the end?
good job. It's both of them.
Hopefully that brought me up to second place because I was the first one.
Alright. I think this is the last question.
Yeah.
What is the minimum number of bits that can represent 2 options?
2 options.
Yeah, if you have 2 options, how many bits do you need?
2 bits.
No!
You're retarded, Daddy.
Oh, actually, I was actually right.
But yeah.
If you have 2 options, like A or B,
1 bit.
1 bit.
Yeah, sorry. That meaning 1
Okay,
bit.
please, Jesus Christ. Please, Jesus Christ. I was
You
the
are
first
right.
one to answer, and I got it correct.
I'm crazy.
No. Your
Yeah.
dad. Nice to meet you.
Good job. Y'all want to play it again?
Yeah, except this time, can we pick our names? Oh, I got
Nobody
second place.
talk on this time.
What?
I got
Y'all
second
all
place.
got 5 right.
Oh, no, I'm watching Kitty.
Alright. Y'all want to play it again?
Dad, or this time, can we
Let's
pick
turn
our
that
own
off.
names?
Yes.
And can you please make it less, like, bring it down to like 1 bit?
Give us the code.
Alright, 359.
359
Yeah.
07 44.
Yeah.
Enter.
You can write your name this time.
Right. Sharif.
What happened? Nina is cool. Y'all hear the low quality?
Can you please turn that shit?
Best.
Everybody ready?
Hold on, I'm not ready.
Oh.
It won't let me go in. Give me a second. Okay, game can. 35.
مين اللي لسه؟ مين؟ جوجو.
George, you ready?
4. No, I'm not ready.
Okay.
Dang it, it won't let me click a nickname. Alright, there we go.
What is your name?
Write something. This time nobody's gonna say anything, so we'll see who gets it first. It's this race. Y'all ready?
Yeah.
Make sure y'all remember.
Jojo.
the information.
What's
What are
that?
you doing?
I'm trying to do my thing.
Hurry up.
What?
Alright, are y'all ready?
One sec.
I'm gonna start without you, Kai.
Alright, there we go.
Easy.
I'm an idiot.
I'm idiot. Idiot.
The
Alright,
idiot.
data representation. How many bits of information can these wires represent? Y'all ready?
Yeah.
How many wires do you see?
I was first.
Good job. Y'all
I'm with the idiot.
Neil got it first.
Ah. Which of the following could represent a single bit of information? True or false? That is two
I
answers.
was the first
There is
one.
multiple
I was the
answers.
first
Yeah.
one. I was the
It's all about
first.
how fast
I
you go.
was the first one.
Good job. What is the minimum number of bits that can represent two options?
Okay, great.
Who got it wrong?
Shit.
You?
That was me.
You got it wrong again?
This is a computer. This is like a mathematics. He's crazy in math.
The quality of this thing
That's
is
normal,
so
that's
low.
normal. Which of these could be represented by a single bit?
There you go. Why did nobody put the seatbelt light?
I don't know.
Alright. Cool.
Dang it. I'm still with the idiot.
Which of these best describes what a binary digit can store?
What?
There you go.
Wait, is this a different one?
No, it's the same one. It randomizes the questions order.
Randomized.
Oh, how many bits of information can those?
These wires represent
Yeah, I was first.
No, I was.
No, I was.
No, I was.
No, I was.
3 bits. Good job, y'all. Y'all are doing okay.
Dang it, I want to
Mina,
catch
Mina's
up.
number one.
What's 1 0 in binary?
1 0 in binary. Eh? What's 1
I
0?
was first.
There
I
you go.
was.
Good job.
I want to get second place.
Alright.
Dang it, I'm still with the
Mina's
idiot.
number 1 too.
Okay, good job.
Alright, can we play one more game, please?
No.
Good job, Yamin.
Please, please,
That's
please,
it.
Good. Yeah.
please,
That's it.
please,
That's it.
please.
Thank you.
I was gonna do a survey.
No, please, can
No,
we
I
do
don't have a survey for you.
one more game?
Nah, we're good. How did y'all learn the lesson? Did y'all
Then-
like me teaching?
Yes, good job, good job.
Alright.